Um, all right. So, welcome everybody to the January 2021 meeting of the Colorado Hydrogen Network. We've got the agenda up here. You can see that. And of course, we'll go into detail as we go. But we've got a couple of presentations from Gold Hydrogen and from Neumann and Esser, as well as we've got the Hydrogen Heroes Awards, which we haven't done for a few years. So, you're all going to want to hear about that. But kind of while we're waiting for everybody to sign in and get through the wickets of Zoom and everything else, um, I do want to talk about this geologic helium and hydrogen conference that's coming up. This is put on by the Rocky Mountain Association of Geologists, and it's going to be here in Denver. So no travel or anything needed by any of us. It's April 9th through 10th. It's going to consist of lectures as well as an exhibit hall. And CHN is going to have a booth at the exhibit hall, as well as we'll present a poster at the poster session talking about some of the financial and business aspects of the hydrogen ecosystem. As I said, presented by the Rocky Mountain Association of Geologists. That's their website there. The event is a little bit pricey. It's, I think, $700 for early registration. But maybe some of you want to consider that just to see what's going on, because really, I think hydrogen is going to be, from geology, that is likely to be the lowest cost source of hydrogen. So this is something important for us to watch. And along those lines, just today, the U.S. Geological Survey released their map of potential geologic hydrogen sources or locations, I guess is a better way to put it, in the U.S. And you can see there's a lot of dark colors here, which is good. That means the probability or the prospectivity, as they say, is high. Colorado's in pretty good shape. Out on the eastern plains, we've got quite a bit of possible geologic hydrogen. This is natural hydrogen, naturally occurring underground. The the white streak here, I'm sure, is the Front Range. Obviously, you're not going to drill for for any kind of. You might dig for gold, but you're not going to drill for oil or hydrogen probably in those areas, which is, I'm sure, why it's shaded that way. But very interesting subject that we'll keep tracking as developments occur here. You know, it's interesting to note the one well that does exist. It's in Nebraska, kind of in the middle of the state, probably about where the S is in Nebraska. A hydrogen well producing natural hydrogen, and that's not even the darkest blue area. So there's a good probability we're going to find some hydrogen in a lot of places. All
Brad,
right.
that well is shut down, by the way. It hasn't, it operated for just a few months and it does have some hydrogen left in the well casing. But as you probably know, natural hydrogen changed its corporate structure and they don't have any current plans to do anything with it.
Thanks, John. Do you know why they shut down? Was it lack of hydrogen or lack of money or lack of users?
It was a test well and they drilled it, put it in and got hydrogen out of it. And so it accomplished its purpose.
Okay. All right. Yeah, and that is our friend Vyacheslav Zagonek. And as you point out, he was a CEO and he's moved on to actually another company that's doing, I think, data and some other things for hydrogen exploration. So, all right. Thanks, John. All right. So, without further ado, I do want to get to the two presentations we've got today. And the first one is from the company Gold Hydrogen. And I'd like to introduce Alicia Dinges, like hinges, as she tells me, and I'm having a little trouble remembering that. But Alicia and I met at the Rocky Mountain seminar that SARAD had up in Boulder at the end of September, beginning of October. And we just did a podcast. You can see their Hydrogen Nowcast, which just came out this past Friday. So, Alicia, I'm going to stop sharing the screen and let you go ahead and give us a presentation. Let us know all about the company and the technology.
Great, thank you. Can you hear me okay?
Yeah, loud and
All
clear.
right, My apologies, my video does not seem to be working on Zoom. So I'm really glad you showed a picture, so at least people had a name to the face. But I was trying to mess with it while we were getting started, and it's just not happening. So we're gonna just roll without my face. I think you're more interested in the in the presentation anyway. So let me get it shared on the screen. Hopefully it's coming up okay.
It's starting to, there we go. We see your whole um, PowerPoint screen.
All right, great. Yeah, so I put together about 4 or 5 slides, really just to give an introduction of our company, Gold H2. Really, we started as a mission to produce clean and cost-effective hydrogen by going into depleted end-of-life oil fields and using naturally occurring microbes to produce the hydrogen in the subsurface. So we're kind of a special niche to the natural hydrogen. That's usually where I would put quotes. Natural hydrogen in the subsurface. This is not like Brian was talking about that you can explore for, but actually stimulate the production of hydrogen in the subsurface using microbes. And so really just kind of going over our overall vision for the company, we're really looking at upending the traditional energy industry and boldly leading the clean energy revolution. I mentioned we are using microbes going into depleted oil fields. So that is kind of where we got the name for our black oil to gold hydrogen technology. And on the next slide, I'll give a little bit more information on that process. So we're targeting, at least in the early stages of our deployment, we're looking at going into end-of-life water floods. So these would be fields that have already been through secondary and tertiary recovery means. We know there's still, up millions and millions of barrels of hydrocarbon in the surface, but it's not economical for operators to produce. Operators are also looking for ways to participate in the energy transition. And so our technology really allows them to, one, have a potential additional revenue stream, and also potentially leave that highly carbon intense hydrocarbon in the ground and instead convert it into a cleaner fuel like hydrogen. So we would go into a water flood, piggyback on that process. Our naturally occurring microbes in a proprietary nutrient package would be injected into existing injection wells. The reservoir would then essentially act as a bioreactor in the subsurface, and the microbes would undergo a fermentation reaction that then produces the hydrogen stream. Now, part of that fermentation process does also produce CO2. So, depending on how much is naturally sequestered in the rock or dissolved in the water, we would have to do some separation and purification to remove the CO2 and ideally re-inject it into a different part of the reservoir. So it's sequestered and we can have a lower carbon intensity to our hydrogen. We would recycle any water, and then we would be able to take the hydrogen to market depending on where we're at. So obviously, oil fields come in many different shapes and sizes and locations. So there's a lot of potentially interesting areas along the Gulf Coast and areas where there's a lot of hydrogen infrastructure already in place, pipelines, et cetera, that we would be able to tap into if we wanted to move the hydrogen that way or take it to market that way. On the flip side, there's also a lot of oil fields that are in very, very remote locations where there's not existing infrastructure to move the hydrogen or use the hydrogen in place. So we've got kind of two offtake pathways that we're considering. The first I mentioned are clean molecules, where we would clean up the hydrogen, we purify it and move it to whatever end use is close by. The other, which would become more favorable in those remote locations, would be actually burning that hydrogen-rich stream through turbines on site and then turning it into what we call a clean electrons to be able to potentially power more consistently powered data centers and other applications like that. So we're trying to plan through, depending on where we're at in the world on a project, what in-use hydrogen would be. I think the overall, really attractive thing about the technology is that it's very light capex because we're going into systems that are the money's already been put into. So we can essentially tap into the existing injection wells, production wells. A lot of these fields also have a lot of the purification on site as well. So being able to really use this existing infrastructure allows us to have the overall levelized cost of production under that dollar per kilogram target that we're looking to achieve. So it's extremely attractive technology. And the current 80 cents per kilogram that our techno-economic assessment projects, that includes if we have to bring in some of the existing, or we have to bring in new equipment and the existing infrastructure is not there. So you can imagine if a lot of the field has that already, then we can get that cost even lower. And it also is a very scalable technology. So once we go into an injection well and produce out of several production wells, the more injection wells we tap into, you can continue scaling up. We expect that we can get about a ton of hydrogen per well per day when we're at commercial scale. So that could easily go into, if you tap into fields of 25, 50, 100 wells, the volume can add up quite quickly. So usually this is where people say, well, that sounds great. So is it ready? Can I bring this into my field? So I like to give a quick overview and kind of history of where the technology began and where we're at today. Back at the end of 2021 is when the research and development for the project kicked off with our parent company, which is another biotech startup here in Houston, where we're located. And we realized really quickly we had a pretty interesting potential commercial pathway for this project. So the company decided to create a subsidiary company called Gold Age 2, and in doing so, raise $7 million in our initial seed fundraising round then to provide funds for further technology development and also our initial proof of concept pilot that we did in the summer of 2022. This was out in the Permian Basin in Texas. It was designed very qualitatively as a yes or no. Can we go out to a single well, put the technology, the microbes and nutrients into a single well in the near wellbore, shut in the well for 4 days, and then open the well up and see, do we have any hydrogen production above baseline? So baseline levels were running about 50 ppm of hydrogen before the pilot. And then when we opened the well back up, we saw up to about 13,000 ppm of hydrogen. So we definitely saw some activity with the microbes in just a short amount of time in that near wellbore. Obviously, it was not meant to be a quantitative commercial scale project, but it was the first proof of concept that we can bring the technology out into the field. So we've spent the last few years expanding upon the technology, looking at other reservoirs that the microbes could work in, and thinking about what that scale-up pilot looks like so that we can reach that dollar per kilogram or less cost and get to that ton of hydrogen per well per day volume that we believe we should be able to reach. So we've also, in the time since the initial pilot, we've constructed what we call our M3, or a mobile fermentation unit. And that would allow us to grow the microbes on site that would be then batch injected into the reservoir for the fermentation process. And early last year is when we were ready to begin these commercial pilots. Obviously needed a little bit more funding to do so. So we started a Series A fundraising round then. And we've since been able to work in several fields, sampling and understanding the feasibility of hydrogen production and gearing up for a few pilots over the next couple of years that will take us from that TRL 5.6, hopefully up to commercial scale and beyond in 2026. So this just talks through kind of what that process looks like. Obviously, so a lot of opportunities out there. We try to have a very streamlined and quick qualification process. So that way, if it's a no, it's a quick no. Being a microbial-based technology, the microbes are a little bit picky on temperature and salinity of the water. So we've understood so far that our tolerance to temperature needs to be less than 85 degrees C. There's also a colder limit as well, but overall, as long as we stick with the not going above that, then it wouldn't be too hot. And then the salinity range needs to be under 150,000 ppm. And once we have identified fields that meet that criteria, then it's really easy to assemble the team to go collect samples, they can bring them back into the lab where we assess what the microbial composition looks like to see if there are naturally occurring microbes there that are capable of hydrogen production, and we'd just be able to stimulate them within the reservoir. And also looking at what the optimization for the nutrient package would be for the best chance of hydrogen production would be. If that all looks good, then we would work towards a pilot where we would do some more in-depth lab analysis that would allow us to do reservoir simulations and better understand what the technoeconomics look like for that specific field. And then we would be able to deploy our M3 unit to do a pilot test. And we try to strategically plan any of those pilots so that if the pilot goes well, then scaling up commercially is very easy from there. You would just start injecting into additional injection wells and producing more hydrogen. And so quickly, I just want to shout out to the team. There's 12 full-time employees working on a very multidisciplinary project. We've got background in biological operations, geosciences, metagenomics, geochemistry, petroleum engineering. So it takes quite a wide variety of expertise to make this project work. And we're very excited about what the future holds. I think my last slide is just kind of our high level, who we are, who our investors are, some of our latest news articles. And last but not least, I would leave you with my email address. If there are any other follow-up questions or interest, to be happy to follow up with you later. Thanks for the opportunity to be here. Really appreciate it.
Yeah, thanks, Alicia, and thanks for your time. So, questions from anybody?
Yeah, Brian, I had one. Alicia, is the fermentation, is it actually breaking down the methane that is still within the wells, or is it actually breaking down the water into hydrogen?
So they're actually breaking down the hydrocarbons, so the crude,
Okay,
and that's what's producing the hydrogen CO2, and as well
gotcha,
as acetate in the water.
gotcha. Okay, thank you.
All right, Keith's got his hand up. Go ahead, Keith.
Yeah, on the couple slides back, you had a bunch of company logos in the lower left. Are those the backgrounds of your staff, or are those investors in the company?
Great question. Apologies for the confusion on that, and that I already I already stopped sharing. Most of those are going to be backgrounds for for who is for our team, where they've worked, at universities they've been part of. I believe the only investors are the ones I showed on the last slide. So we have,
Okay,
yeah,
great. Thanks.
apologies for that confusion.
Yeah, we in the chat window, Bill Eady out in um, Alaska had a question. He said, would greenhouse gas products be gathered, moved, delivered to customers or end users, steel pipelines? So a bunch of questions here, but the maybe what we could address, Alicia, if you're willing to talk to it, is that the stream of hydrogen coming out of the well isn't perfect. It needs some filtering and modification. I don't know if you want to talk to that or not.
Yeah, I can speak briefly to it. One thing we learned early on, right, is anyone in this industry, it's all about partnerships and collaborations. No one can do it alone. So we early on learned, right, we're the subsurface microbiology experts. When it comes time to production and purifying and moving the hydrogen, that's where we're going to lean into the experts in that field. But yeah, certainly we would need some purification if we were going to move the hydrogen. Now, I saw some concerns of the pressure to avoid embrittlement. So all of the fields that we're currently looking at going into are end of life depleted fields. So the pressures are generally much lower, where you wouldn't necessarily be concerned with hydrogen embrittlement, but it's certainly something that we would do a whole asset integrity risk assessment in any field we would go into to make sure that the steel would be able to handle the hydrogen. And if not, be able to partner with the right people that could do liners or sleeves to help with that.
Okay. All right, Howard
Brian
Gerwin
and
has his
Bill.
hand up. Go ahead, Howard. Howard, you're on mute.
Sorry, I had to find the demute button. So quick. So first of all, how deep is the snow? How's the snowpocalypse?
In
It,
Houston?
yes,
Yeah,
yes,
no,
I didn't get to tell you. Yes, we got about 6 inches in
Wow.
Houston, which is pretty wild. So the kids have been home from school and having a blast in it all day. Although now it's 40 and sunny in melting.
so, I just wanted to comment on that. I'm also a fellow Rice alum, so I just felt I had to jump in there.
Awesome. Love it.
Other questions? Well, I will add
Brian,
one thing that
Brian,
we covered in the podcast, and that is I kind of played devil's advocate and say, why do we want to do this? Well, part of the reason is there's an awful lot of abandoned oil wells out there. I mean, Colorado's got over 20,000. They're all over the world, and it's my understanding that most petroleum wells still probably have half the energy in them just because it's no longer economical to recover those. I'm sure that varies a lot, and I don't know that if that's a good heuristic or rule of thumb, but there is quite a bit of energy to be had underground, and this is a very low cost, could be a very low cost way to get hydrogen. Okay, it's not renewable, but it could certainly be 100% clean, I think, if we're careful with these, because we're not really bringing the carbon out of the ground. It's just really the hydrogen that's coming out. So anyway, I think it's very important, as is the technique of proton technologies, or now proton H2 up in Calgary, also using oil wells, slightly different process, and then of course natural hydrogen, which we spoke to earlier. I see those three as holding an awful lot of promise for hydrogen to compete, especially with diesel for the big rigs, as well as to compete with natural gas. So, all right, Elliot, you've got your hand up. Go ahead.
Well, my partner put up a question in the chat box there directed towards Alicia. He's on the phone. He's on a phone, so
Oh, okay.
No worries.
The question is, how do you measure or detect the presence of hydrogen in the reservoir, and what technology and what parameter do you use? I'm not sure about that last part, but
Yeah, great question. So we don't have means to actually detect within the reservoir. So we're relying on the produced stream and measuring from there, whether that be through some gas monitoring or using GC. We have a mobile GC right now that we would bring to the field to use. Obviously, talking to a lot of companies on various new technologies for measuring hydrogen. And what technology? I think that was that's I think part of the same question.
I think we'd like to talk to you at some point. Reach out to you.
Okay. Yes, I
All
think
right,
I
thank
got
you.
I got
Yeah.
your note.
All
So
right, thank
yeah,
you.
happy to connect. Thank
Thank
you.
you.
all right. Oh, Billy, you've got your hand up. Go ahead.
Brian, can you hear me?
Yep, go ahead.
Great. I was primarily concerned about pipelining hydrogen. If these wells, the productive ones, are going to be rather scattered over the countryside, how are we going to gather and then transmit to the end users? Do we have any word yet from the High Blend project? Maybe Keith Whipke has some insight on that, because NREL's involved on being able to tell us what blend percentage, if any, can be tolerated, and how that is going to depend upon the pressure fluctuations, and can these sources be controlled in some way so that we eliminate the kind of pressure fluctuations we'd expect from wind and solar, for example. So how do we get this to market, and what's it cost by the time we get it to the dispenser? Thank you.
Yeah, I'll take a stab at that, Bill. Based on the quantities that it sounded like these would be producing, 1,000 kilograms a day, if I remember that right. It probably would be a pretty low percentage in a natural gas pipeline or transmission pipeline. So I don't think it would probably be a concern. Certainly, if you needed to add a bunch of new dedicated hydrogen pipelines, that would probably be prohibitively expensive for these smaller generating sources. That's my guess.
Well, and of course, there'd be an evolution of the way this is deployed. For example, maybe initially you've got a data center that needs a huge amount of energy. Locate that very close to the oil fields, and then you could have a very short pipeline, might even be on your own property just to get that there. Then once that's operating, you could liquefy some of that hydrogen and use it for, Elliot's shaking his head, use that for transportation because we need that cost of hydrogen in order to compete with diesel for the big rigs. So, I mean, the evolution here is something to be considered how this develops, and it's going to be some market forces, so it may be a little bit hard to predict till it actually happens. All right, I think we have time if there's maybe one more question. No? All right. Well, thank you, Alicia, again, and thanks for your time to do the podcast that you did with me. I think that's going to be a really popular episode. So
Thank you,
next
Brian.
up, we have Luis Soriano, who's a key account manager with, I'm pronouncing it Neumann and Esser, but Luis, straighten me out. Do you pronounce it Newman or Neumann?
Yeah, I go with Newman, but if you ask my German colleagues, they're probably gonna say Neumann.
Yeah. All right. Well, I've got a few
You
German
are
roots,
good,
but
Brian.
all right. Luis, I'm gonna stop sharing and let you share and tell us all about the company and the products and technology and all those things.
Sure. Can you guys see my screen?
It's coming through. Hang on. There we go. Got it.
All right. So, yeah, thank you, Brian, for the opportunity. My name is Luis Soriano, Key Account Manager at Newman Esser. I've been with the company since 2023. Have about 13 years of experience in hydrogen compressors and now growing to learn about other products in our portfolio too. I am based in Houston as well. We are living the apocalyptic scenario of 3 inches of snow where I am, which is pretty bad for people in Houston, but we are hanging in there. Yes, so we will share with you guys some information about Newman Esser. We are an integrated solution provider across the hydrogen value chain and looking forward to working with you guys in the future. Yeah, a little bit about Newman Esser. We consider ourselves a leader in hydrogen management technology. We are a pretty old company, founded in 1830, and we are a business family owned since 1891. We are now the fourth generation of Peter's family members running the company. We get our compressors from Germany, so the main factory in Germany, we bring to the US or other regions and do local packaging. So we are very proud about the quality of our products combined with local expertise. Here for the US market, all our project engineering, detailed engineering, project management is all done through the office in Katy, Texas, where I am located. And we have been supporting clients primarily from the oil and gas industry for more than 30 years out of the Katy office. In terms of number, we are around 1,700 employees globally. About 10% of that workforce is here in the US at the Katy office. We have a pretty big install base of compressors, more than 5,000 compressors globally. And out of those 5,000, we have more than 2,000 hydrogen compressors, which I will share with you in a bit, a few recent examples. And we have been doing hydrogen compressors for roughly 100 years. So in terms of hydrogen compression technology, we did everything. We compress everything in terms of pressures and flow. We're a pretty wide reference list on virtually any application in the hydrogen value chain. What we do? We have basically three different product lines, and I'm gonna touch on each one of them briefly for you guys. First, we have the electrolyzer systems. We are offering to the market now modularized PEM electrolyzer systems made in the US. We don't make the stacks. We buy stacks from companies like Plug and Bosch, and we provide the entire balance of plant in containers, this one you see on the picture, and I'll have a few other pictures to show you guys. Each module can have up to 5 megawatt capacity, which gives you around 90 kilograms per hour. And it's it made in the US, as I said, and meets all the relevant North American standards, either for US or Canada. Second here in our portfolio are the compression systems. As I mentioned before, this is our bread and butter business. That's where the bulk of our revenue comes from. And we can do very, very large reciprocating compressor units that are feeding refineries in the Gulf Coast, all the way down to 10 horsepower, 900 bar diaphragm compressor in your hydrogen refueling station. So a pretty broad portfolio for hydrogen compressors. And we are now, because we have the compression technology, the electrolyzer technology, we are expanding to offer integrated solutions. We can provide hydrogen filling stations today for various applications like tube trailer loading, unloading. For the mobility market, 350 bar, 700 bar. Some other applications that are picking up some steam recently in the US are fuel blending, where we provide the electrolyzer for on-site hydrogen production and a blending skid to mix with natural gas and fuel burners, for example. Yeah, if you guys have any questions, please feel free to ask your question at any time. Otherwise, I'll just keep going here. In terms of electrolyzer system, this is a 3D model of our module. So this module is scalable from 50 kilowatts, which is very small, all the way to 5 megawatts. And you can have multiple modules in the same site. Using this modularized concept, you can, in theory, go up to 50 megawatts, just getting the entire scope for the hydrogen production unit in containers. We do have some projects in Europe that are going with 20 megawatts, maybe 30 megawatts. There is a lot of considerations about when to choose the correct design for your project, but definitely modularize it for small to medium size projects is a really good way moving forward. On the system, you get almost 18 kilograms of hydrogen per hour per megawatt, and you get a lot of oxygen as a byproduct, about 142 kilograms per hour. The hydrogen discharges the system at 30 bar, and the oxygen discharges at 3 bar. The purity of the gas out of the stack is 99.9%. If we need to provide fuel cell grade quality 99.999 or 5.0, we install a PSA unit inside the container that's provided by Newman Esser as well. The oxygen has very high purity, but not commercial grade. Most of the clients today are venting their oxygen. A few of them are looking to purify and sell it, but that's something that's just not occurring very often. You can have a pretty wide turn down range. The ramp up and ramp down, the system is very fast. That's typical of a PEM technology. And you can turn down the system all the way to 20%. And the availability and uptime is about 98%. This is a 3D, another view of our small platform. You can see here on this side, on the right side, the PEM stacks, on this case 2. On the module, you have what they call an oxygen loop or an anode loop and a cathode loop or hydrogen loop. Those are separated in different systems across the container. If you are familiar with PEM stack, if you're not familiar with PEM stacks, they need ultra pure water to protect the stack and avoid degradation. And in order to produce this ultra pure water, there's a lot of water treatment systems inside the container. Those are all these pumps and heat exchangers that you see. The PSA unit is on the right side as an optional item. And on the other side, we have some other water treatment filters and the PLC panel. Each module that we provide has a separate power supply unit that will have the rectifiers and the transformers. So this is the small platform. So all the scope goes in a container. You have a second container just for the power supply. In terms of utility requirements, I get this question from clients very often. What should I provide to the stack? I decided to put a slide summarizing the utility requirements. The system can pretty much handle any voltage available at site. The transformer is optional in our scope. You don't need to buy from Newman Asser, but the rectifier is always in our scope. But the transformer, if the utility company can provide a transformer, that's fine. And the rectifier is going to regulate the voltage and current going into the stacks. Since it's part of the stack capacity control, we prefer to provide a rectifier. In terms of water consumption, you need about 14.2 liters of raw water per kilogram of hydrogen. The system will produce around 10 liters of ultra pure water per kilogram of hydrogen that will meet the stack requirements, primarily for conductivity. And a lot of that water is actually circulating through the stack, but to cool down the stack, as you probably know, is an electrochemical reaction that generates heat. Most of this ultra pure water is just cooling down the stack, and part of the water will actually be split into hydrogen and oxygen. We need some instrument air to control solenoid valves and some actuators. It's just industrial pressure. And have a pretty wide ambient temperature range, minus 20 C to plus 40 C. If you need the system to be designed for lower or hotter temperatures, we have a hot weather package and a cold weather package that is available upon request. This is just a reference project. This is the first megawatt scale electrolyzer system in Brazil that is producing green hydrogen today at a seaport in the Northeast area. Newman Asser provided the entire solution, including power supply and remote monitoring systems. It's 1.3 megawatt and was fully commissioned in December 2022. And the company is EDP Renewables. As mentioned here on the last bullet point, we have condition monitoring system that we have in our portfolio for a few decades, but now that's for the compressor product. Now that's being also deployed into the electrolyzer system. In terms of experience, there's a lot of activity in Europe and in South America. Right now, this slide says above 40 megawatts, but the actual number is more likely around 80 now. We are selling some very large systems in Europe now at the moment, and here in the US is picking up momentum as well. But as you can see, we have quite a good number of megawatt scale projects in the pipeline, and the list keeps growing. Very nice to see this product complementing the portfolio, really taking off in other regions. Before I move over to the compressors, let me see if I have any questions here. Okay. Any questions from the audience, or can I just move forward?
Yeah, I would say keep going.
All right. So now moving over to compression systems. As I said, this is the bulk of our revenue. That's where we have literally thousands of units deployed in the field today. When it comes down to hydrogen compression, you have two different technologies. You have the piston. Well, we actually have more than two, but the most common ones you see in almost every single project with hydrogen is either a piston reciprocating compressor or a diaphragm compressor. Both of them are positive displacement machines. Some applications you may also see screw compressors that are positive displacement machines as well, but we don't have that in our portfolio. And there are like a few technical reasons why positive displacement compressors are the best solution for hydrogen. It has a lot to do with the molecular weight of the gas and the efficiency that these compressors can have handling that lightweight gas. That's probably subject for another discussion if you're interested to learn more. But I can say for surely that the majority of the hydrogen projects we are working today use one of these two types. And the hydraulic driven compressor is more like a a niche application for small flow projects. In terms of reciprocating compressor, a piston type, we have three different designs. The vertical compressor is an excellent choice for non-lubricated services. You can reach up to 1,000 bar on them. For non-lubricated hydrogen compressors, we can now deliver up to 500 bar on a reciprocating compressor, getting the gas out of a PEM electrolyzer at 30 bar. So this is very, very important for heavy-duty refueling stations that need a lot of gas at 500 bar for 350 bar filling. This vertical reciprocating compressor is an excellent choice. But there's so many throws you can have, and there's so many cylinders you can put on a vertical arrangement. So when the compressor gets really big, you will see horizontal arrangements like this one to the right. On this particular design, then we can go up to 8 cranks, 8 stages, and 30,000, around 30,000 horsepower. They can get pretty big. This is what you see on a refinery worldwide. You'll see hydrogen makeup compressors. Almost all of them are reciprocating horizontal receipts. And we have this V-type here is more like a niche application for small projects. You can put up to 2 cylinders on the same throw and up to 4 stages. Now, just for you to have some reference, why reciprocating compressors for hydrogen applications, and I mentioned that on the previous slide. The number one reason why use a recip on a hydrogen project is efficiency. So they have very, very high polytropic efficiency, around 92%, in average more than 5% higher than a similar turbo compressor for the same application. They can also have a pretty wide turn down capabilities while delivering a constant efficiency. So that means you can keep that efficiency very high even when you are turning down the capability. So a lot of clients, they want to do what they call load following. So if your electrolyzer, for example, is decreasing capacity, you want the compressor to decrease the power consumption proportionally. The reciprocating compressor can do that at constant efficiency. So that's a very, very important feature for, especially for green hydrogen projects. You can have relatively high compression ratios per stage, 3 to 4. So that means you have reduced process gas equipment like piping and coolers, and you can have pretty high discharge pressure on those machines, up to 10,000 pounds. Yeah, a lot of times we compare different technologies for clients for their hydrogen projects, and we provide all the technical justifications why to use reciprocating compressors. That's actually where I spend a good amount of my time these days. Just a few more information about the diaphragm compressor. This is the application that you see in the mobility market, for example. We talked a lot about the mobility market here on the meetings with Brian and the colleagues. They can handle very high pressures very well, but they are somehow limited in flow. So on a single machine from 30 bar to 500, you can roughly get 60 to 70 kilograms per hour on a diaphragm compressor. And if you're talking about higher flows, then you need more units. And that's where their limitation is. But they are oil free. There's no oil leaking into the gas stream. They are abrasion free. Virtually no leakage out of the diaphragm, and they don't require purge or buffer gas. You can have up to 4 stages and 2 cranks and 400 horsepower. One of the nice characteristics of the diaphragm compressor, they have higher pressure ratios per stage. So any given application, if you need probably 3 or 4 stages on a recip, a diaphragm can do the same working too, which saves a lot of equipment. They require a bit more maintenance than the recip, so they have shorter uptimes. And that means you have to open up the heads that you see here and replace the diaphragms roughly every 6 months. So very common to have spare units on critical services. So you can keep the plant running at partial load while you replace the diaphragms, but they They have been around for quite some time, not new technology, and we have a few thousand of them in hydrogen today, all over the world. Just a couple references from real projects. This is a hydrogen pipeline compressor installed in the Gulf Coast. This is getting hydrogen out of SMR and feeding the pipeline at from 400 pounds to around 1,200 pounds into the pipeline. Is a fully skid package unit and two-stage. That's very, very typical application for hydrogen pipeline. This is running into the pipeline of a major industrial gas company in Texas today. It's fully packaged in our packager shop here in Brookshire, Texas. The other example, this is a loading unloading tube trailer application. This is a three-stage diaphragm compressor, 300 horsepower. This is as big as it gets on this type of technology. Is approaching the limit of diaphragm compression technology, 2.4 tons per day at 550 bar. And there's two of those, so there's a spare unit. This is installed in a facility in Ontario, California, feeding tube trailers of another major industrial gas company. So this is a configuration that I'm seeing quite often in heavy-duty refueling station projects. Just moving to the last component of our portfolio, which are the integrated solutions. So this is a product that we are rolling out to the US now, and we are again bringing from Germany, bringing the technology from Germany and South America, where we have the engineering offices that do the design for the systems on a global level, and we bring that design here to the US and we localize to meet the US standards. We have two different concepts. We can have an on-site production unit, which will be the Hytrom electrolyzer I showed you guys before, or we can work with other hydrogen sources. I am working today with clients that want to use methanol reformers and just have us providing a scope downstream the reformer. Or sometimes clients want to use another electrolyzer, or they have a hydrogen or as a byproduct. On those scenarios, we can provide a scope downstream the on-site production, which would be the optional PSA system, compression, storage, and distribution. All this equipment provided by Newman Esser. This is like a 3D model of a real station that we deployed in Brazil last year inside the Federal University. This station has an on-site hydrogen production system. It's about 300 kilowatts. You have a pretty large buffer tank. It doesn't need to be that large, but this client wanted some hydrogen store on site. You can see the compressor in the middle of the 3D model. The low pressure hydrogen storage tank at 500 bar for 350 bar filling. And then the high pressure 900 bar storage for 700 filling. You can see here in purple the dispenser, and this pink color here, that's the cooler for minus 40 C cooling to achieve faster refueling times. There was a lot of space available on this site, so that's why the equipment is spread out. Normally, clients don't have that much area available, so we try to minimize the station design to fit whatever area is available. Yeah, so in terms of capacities, we can do up to 10 megawatts on a hydrogen station like this one. I have an example to show you guys in a minute. Once we design the production system based on your hydrogen consumption needs, we obviously design the compressors. That's what we have been doing for a very, very long time. We buy the storage systems we design and purchase the storage systems here in the US. And we qualified today 2 or 3 suppliers of dispensers that we can buy the dispensers from them and integrate into our solution. What is included in the Newman-Esser Hydrom filling station? We provide to clients the base as basic scope, equipment engineering, system engineering, equipment delivery to site, on-site systems integration, full system warranty and limited performance guarantee. That's included for single one of the stations we quote. And there's a lot of optional items, primarily related to services. We have a fully staffed services center here in Katy that serves the compression fleet we have in the US. That team can also provide commissioning startup for the station, personal training, personnel training. There's an option for a condition monitoring system with remote monitoring capabilities. That means clients can have a reliability engineering sitting in our control room in Katy, monitoring the station for you. And that's something that the clients are very interested to. We have um, a lot of data that's generated by this system, and that data is fed back to the control room in our office in Katy, and we can help with troubleshooting. We can do spare parts supply and inventory, provide maintenance as required or under a long-term service agreement. So operational support is something that we are very good in doing because we're doing for the compression industry for the oil and gas industry for decades. What we don't do site preparation, we don't do permitting, we don't operate the system, and we don't provide power. So normally, this is not a big problem for clients. They work with a civil contractor to prepare the site for the station. Obviously, you gotta have permits and things like that, and find people to operate. We will provide all the training. This is an example of that station I mentioned to you guys in Brazil. You can see all the equipment here. The Hydron PEM electrolyzer stack is in the back. You can see the high pressure storage tank, the medium pressure storage tank. That's the big buffer that I told you. They didn't need it, but they want it. And in blue here in the middle, the hydrogen compressor, diaphragm compressor.
Hey, Luis, I'm sorry to interrupt you. We're starting to run out of time. Maybe I can get you to kind of wrap things up here in the next couple of minutes.
Yeah, that's about it, Brian. I think
Oh,
that's
okay.
my last slide. I'm right
Oh,
on
I'm all
time.
right.
Yeah.
I'm sorry to break in on you like that.
No, no problem.
There are a number of questions in the chat for you that are pretty detailed, and I don't think we're going to have time for those. But maybe, Luis, if you could capture those and respond. I know Bill Leedy's got some questions, Chris Allo of
Right,
Electric
sure.
Green as well. But I think these are pretty detailed questions, and we're just out of time on that, I'm afraid.
Right. No, no problem. We stop here, Brian. I know it's a lot of things,
Oh,
but I just
yeah.
want to give you guys a high level information about what we are doing. Um, the last one here is this 10 megawatt system in Germany that will have pretty much the same scope of that 300 kilowatts, but on megawatt scale. That's under construction now and can provide additional references as required. And I think that's it for me, Brian. I will stop sharing.
All right. And Luis, you don't have your email on a slide, but maybe if you want to put that in the chat, or people could certainly um, either reach you through me, I would say.
Right. I'm gonna post my contact information in the chat, Brian. Thank you.
All right. Okay. Well, I am going to press ahead because I'm afraid we're not going to finish otherwise. But Luis, thank you for the presentation. I think it's really interesting, and hopefully you'll hear from some of the folks in the organization here. All right, we're going to switch gears a little bit and talk about something we did, gosh, 5 years ago, and doing it again, called the Hydrogen Heroes Awards. And what this is it's presented, of course, by the Colorado Hydrogen Network, and it's to individuals who have really given of their personal resources and creativity to help deploy the hydrogen infrastructure as a means to decarbonize our energy systems. So we're not talking about just people doing things for their job. This is above and beyond that. The award unfortunately, it doesn't carry $1 million like a Nobel Prize does, but there's a very nice wall plaque that goes with this. And the awards at this time are to Brendan Donor of Breathe Transport, Jane and Chris Allo of Electric Green, and Seth Terry and Buford Barr of New Day Hydrogen. I'm going to let them speak for a couple minutes, but I know they've done presentations. If you've been on a number of our past meetings, you probably heard them speak before. So to start with Brendan, what he is doing that earned him this reward, I guess I'll say, is providing a fuel cell EV rental to the general public. And on top of that, the hydrogen fueling is provided because, as you all know, we don't have any fuel stations yet in town. And he's making this car available through a company called Turo.com, which is kind of like an Airbnb for cars. So what Brendan did was he personally financed both the Toyota Mirai, and I'll let him speak to this in a minute here, as well as the mobile hydrogen fueler from Electric Green. And what this is going to do is it's going to enable people in our area to basically try a fuel cell EV firsthand and give it a rental. So here's what the award looks like. And Brendan, I saw you were on earlier. I assume you're still there. Do you want to tell us a little bit about your motivation for doing this and kind of where you hope this is going to take things and what you hope to accomplish?
Yeah, thanks, Brian. So yeah, thanks so much for the award. Super honored just to be part of the company of the group getting the award this year. And so yeah, the reason I did this and I'm doing this is I've always had a huge passion for doing something with my day job to help save the planet. And so my day job is with Pilot Flying J, and things were just going a little too slow with Pilot and wanted to make sure I could get started today. And also was inspired by your podcast. I think it was probably around podcast 50 or so where I got the idea in my head of what could I do to maybe help start the market and get something in people's hands so they could actually, drive and touch a hydrogen vehicle. So, that was really the motivation, and excited to get the car rented. Probably in the next couple of months, I'll be producing green hydrogen here, and we'll have it available for rental.
Well, I definitely plan to rent it, so let me know when you're up and running. I'll just go for a joyride, but hopefully we can kind of show it off. I don't know if you're planning any graphics for the car, but that would be nice.
Yeah, yeah. At some point, I definitely will. Once I get a little bit of money from the rentals. So,
Yeah,
yeah,
yeah.
maybe we can take it up skiing and do some type of a video or something like that
Yeah,
to help market it.
absolutely. Or even just camp out at a few shopping centers or something and talk to people walking by. But um, really, I'm inspired and I'm really honored you're part of the group here to spend as much money as you did out of your own pocket to do this. Hopefully, the rental helps you recoup some of that. But the Colorado Hydrogen Network is a very grassroots organization. We don't have any high rollers, big dollar, deep pocket kind of things in our organization. And so I think it's things like what you're doing that really help move us along.
Well, thanks, Brian.
Yeah,
Yeah.
thank you, Brendan. All right, so the second of the three awards is to both Jane and Chris Allo for basically two things: providing low-cost hydrogen infrastructure for both home energy storage as well as vehicle hydrogen fueling. And again, just like with Brendan, they've devoted a lot of their own personal time and resources for the engineering, design, and manufacture of the products that they're doing. And they're making these products available. Really, they're unique in the market. The home energy storage using hydrogen, there aren't many of those out there. The small scale mobile hydrogen fuelers, I don't know of any of those. There may be some, but I'm not aware of those. And then they're also planning, they've got on the drawing boards, and of course, Jane and Chris, you can speak to that, but the larger scale public hydrogen fueling devices. So here's the award. Two plaques have gone out, one for Jane and one for Chris, so they can each have one in their own office. But Jane or Chris, do you want to comment about some of your motivation for doing this and kind of where things stand and where you see things going?
Yeah, Brian, this is Jane. So first off, thank you so much. We are really honored to receive this award. And honestly, if I might say so, I think you probably deserve an award yourself and all your accomplishments and dedication to this cause. So appreciate that. I did prepare a short presentation if you want to see that real quick. It shouldn't be too long.
Yeah,
I
please
can
do.
just share real quick here. Um, I think, is it coming up? Oh, there we go.
Starting to. There it is.
All right, excellent. So, really, why we do this? Why is it not moving forward? It doesn't want to move.
So the winds have shifted our dish that goes between
Oh,
our house and Lions. So we're not getting full capacity. So
okay. So maybe I'll just end that and talk to people. It's not wanting to move forward. It's frozen, apparently.
Mhm.
Sorry about that. Okay, so I just need to stop sharing. Let me just stop sharing here, Brian.
Okay.
Sorry. Well, that's a
Technology's getting better,
disappointment.
but
Well, okay, so getting to the point of why we started Electric Green. So we incorporated way back in 2015. Chris and I both have been living off grid for over 20 years. And along the way, it came to us that there had to be a better solution than traditional batteries. And so Chris saw this hydrogen battery example, and kind of the light bulb came on for us. And not only with the possibilities of getting away from batteries, but also really improving the environment and really doing something for our environment, and moving forward from our burning of fossil fuels and that for our electricity and transportation needs. So both of us kind of bring our own unique passions to Electric Green, and I think it makes a great team. And we are truly striving to better the environment and lives around the globe. So that's kind of the why. And then the what and what we do is, as you mentioned, Brian, we have a product that is dual purpose, and it can do both hydrogen refueling and electrification, or both if you have that need, we have that solution. And we've developed a patented hydrogen-based energy storage and fuel production system, as I mentioned, that really can provide that electricity for days and weeks, or hydrogen fuel on demand. And so with that, we can put that unit in a home or a business, a small business, or even a microgrid situation. So we can do quite a range there. We have probably we can say a small scale solution that would provide somewhere between 5 and 20 kilowatts of power, all the way up to a megawatt. So it has quite a span. And then we also have our Electric Green fueling solution, which is also designed to be scalable. So we can provide a system that can be all-inclusive in a trailer, a standalone system, or a delivered container unit. And we can produce 5 kilograms all the way up to 900 kilograms per 24 hours. So really from very small scale all the way up to commercial scale refueling for that usage. And the nice thing is that we do store all of the hydrogen at low pressure, and we have redundancy in each aspect of our system. So that ensures both safety and dependability. And our systems can fuel, our very small systems can fuel 5 kilograms in about 2 hours, while our larger commercial scale system can achieve 5 kilograms in about 3 minutes. So we have a pretty good span there as well. One of the things that we are very proud of is that we have integrated the components of the system using a patented software process that ensures the system is efficient and has built-in safeguards, and it automates and thinks more like a human. So it learns and predicts and responds. And then we also have a patent in process on our intelligent energy box, which is a solution that can be installed with any passive solar system, enabling the use of solar irradiance that's generated even when the grid goes down. And of course, it works with all of our systems as well. And then we currently have a provisional patent underway with kind of a first in the world hydrogen fuel booster system that's capable of producing 350 bar and 700 bar pressures. And like I mentioned before, it can fill in that 5 kilograms in about 2 hours and as little as 3 minutes. So that's kind of what we've been able to accomplish so far. And with just one small investment outside of Chris and I, we've basically funded Electric Green to this point. And then we've been really fortunate to have made some sales and are definitely making huge strides to bring the hydrogen economy right here in Colorado and across North America and even globally. So we believe hydrogen is the future of clean energy, and we believe the future is today. So we're
Well,
all
thanks,
in it
Jen.
together. Yeah.
Don't lose that hope and that idea, definitely. Chris, did you want to comment a little bit too?
Just just real quick, part of my passion was to bring this to the US. So we see a lot of components that are made foreign. And so what we're doing is part of Electric Green's technology is to bring this local. So we do have a new compression technology, which will be done locally. It will be done in the US. We're looking at electrolyzers to be done in the US. And then we're going to tackle fuel cells to be done in the US. I guess it helps a lot having tariffs and whatnot from other countries, but that's not the original reason here. The reason is we need to do it here. And so that's part of our passion is to do it here.
Well, thanks, Chris, and thank both you and Jane for stepping out, taking a little bit of risk here, sticking your neck out, putting some skin in the game, as they say, to do this. And I wish you the greatest success. I know the small fueler was at the Colorado Hydrogen Day that we had down at the National Western site in October. So any of you that were there got a chance to see that, and that I really see a good use of that for, say, a company is going to build some hydrogen trucks or whatever, and they need a little bit of fuel, but they don't want to spend a huge amount of money on a big commercial system. I see that as ideal for that, just enough to fuel a couple trucks a day, maybe a truck a day or something like that. There's a real market for that. So I expect that's going to take off here soon. I hope it does.
Well, just quickly to expand on that, Brian, is we have the trailer. We also have our containerized solution. So you can, in a 20-foot container that can be dropped off and do higher rates of output, and all the way up to a 40-foot container that would have our our fast fill boosters installed in that with storage as well as electrolysis. So those are also solutions that we're doing that take us in that medium scale. Trailers are nice. Right now, our trailer is outside in the blizzard, It's running away, but it's sort of funny to see it in the blizzard. But the idea is to have that whole step. Trailers for those that just want the small thing. We do the containers now, of which we're putting a lot of bids out for those containers, as well as our fueling stations, which all based off the same technology.
Yeah. Well, the difference that Electric Green has brought to this that a few other companies that have tried to do these small fuelers is your volume to price ratio is very much better. A lot of those small systems are so expensive. It's just like why would we even do this? And I'm not privy to all your pricing, but from the little bit I've heard, you guys really have something unique there, and I applaud you for it.
Well, thank you, Brian, but don't get hung up on the small side of things. I
No,
mean, the
no, no.
small side was just to prove the technology in the basis of the scope, and the scope was to be able to take this further and further, and that's where we're currently at is the large scale systems, and we'll be putting those together, whether for local companies or for other companies that we're currently looking at for
Right.
our fast fill systems. So
Well,
Well,
but
well,
go
yeah.
ahead, Jane. Go ahead.
And I would add that we are still hitting that sweet spot of the smaller size systems for some of our clientele that they really do appreciate that. And our you're right, Brian, about our prices. I mean, you really can't beat it. So
Mhm.
I think when you sit down and compare, it just makes more sense. And it certainly was initially designed for that, small is beautiful
Mhm.
concept. So,
Well, and we're starting a market, and so you have fleets that are willing to get maybe one truck. So, you have to start small, and the nice thing about us grassroots folks is that we're interested on the small side because that's where our financing and other things lie. The big companies are ignoring it because they've got a big overhead to cover, and so unless they have a big throughput of money for those projects, they're not interested. And so, um, anyway, not to go too long and eloquent about that, but I think there's some real secret sauce there for some of these small systems and starting there and working up. So,
yeah, thanks a lot, Brian. Really appreciate it.
yeah, thank you both again. All right, so to continue here, what happened? Here we are. Um, with our last award, get my screen to come back here. Is last but not least, of course, to Seth Terry and Buford Barr of New Day Hydrogen. And they've really been able to start this hydrogen fueling market by bringing not only just the fueling stations, but also going out there, beating the street, enlisting those commercial fleet customers. They've also spent quite a bit of time trying to locate available vehicles. Some of these are one-of-a-kind prototypes or kind of rehashed gasoline and diesel. And then they've also gone out and gotten quite a bit of financing and grants to help fund all this. And both I've known Seth and Buford since the beginning. I was involved in starting New Day Hydrogen and since stepped back, but they've been devoting 4 years of their life and their personal resources to this effort. Hopefully, we'll start getting a paycheck here one of these days. But I think their unique thing that they've brought is providing a complete solution in the marketplace. So here's the award, and I know Seth had a conflict, but Buford's on, and Buford, if you'd like to just tell us just a little bit about past, present, and future of New Day, that'd be great.
Of course. Definitely, Brian, thank you to you. Thank you to the Colorado Hydrogen Network for recognizing what we're doing. We're, very honored to be here with Chris and Jane and Brendan, kind of the tip of the spear as we're trying to advance this hydrogen market. There's your, you know, your plaque. But yeah, Seth unfortunately could not make it to today's. He's out there trying to drum up some financing for the company. But Yeah, we're focused, as you indicated, on the hydrogen fueling stations. We really see that as the low-hanging fruit for the movement into this market, as opposed to the big utility scale that gets so much of the press, that's out there. But thinking starting small, that's what makes sense relative to a nascent early stage market. Where do we see this going? We've got a grant that allows us to establish 3 stations in Colorado. 3 stations in the entirety of a state isn't a whole lot, but it's a start. Um, you know, our intentions are to basically just start connecting the dots. Everyone talks about hydrogen working in the heavy duty trucks, hauling materials from, Tennessee to LA. Well, you're not going to do that until we're able to get the infrastructure in place. So our thoughts, our approach, our business model is to start, planting these seeds in some of these, along some of these corridors like I-25, and then starting to connect those seeds, continuing north into Wyoming, south into New Mexico, and then starting to make those dots connect together where we can start, having a broader reach, a broader fueling infrastructure out there for our customers, so they are able to reach from beyond just Denver, beyond just Colorado, into the other states, and then hopefully at some point, if all of us are successful across the U.S. So, like I said, starting small, we see that as a way to kick this off, get it going, but starting small is a way to grow something into a large, hopefully, nationwide solution.
Well, I really thank both you and Seth for not giving up. I mean, this has been a lot of years of not no paychecks coming in, so to speak, and there's been a lot of no's and closed doors, but there's been a lot of yeses and positive things going on, not least of which are the 3 grants that you've got going. And um, just thank you for not giving up.
Thank you. And that's obviously, one of the commonalities between us and Brendan and Chris and Jane, that we're all in the hydrogen space, but we've all been donating a lot of, blood, sweat, tears, money, time away from families, all of that stuff, trying to get this going. And I know everybody on this call is doing the same, but that's what we get for being the tip of the spear, for being that advance. The advancement of a technology of a concept. We're willing to do that and push as far as we can with the hope that collectively we're able to burst through.
Well, thanks again. Let's keep the dream alive, and let's show the world that grassroots can win the day and can make some real significant inroads here.
Thank you. Hey, one last comment I'd like to make is, I met Chris and Jane and Brendan predominantly through CHN. So, big fans of what you're doing here, Brian, and really appreciate the efforts that you're doing, because I do think that's a way we're going to continue to grow this. We're going to continue to bring more people into this effort. So appreciate your efforts and in keeping us moving forward.
Well, thanks, Buford. I mean, that's why we call it a network. I mean, the whole idea is to just bring people together. I mean, I know Seth heard me through the podcast initially, and I met you, Buford, through a mutual friend and so forth. But
Yep,
yeah, let's keep it going. And like I say, let's show the world that the grassroots approach is really successful here in Colorado.
agreed.
All right. So back to some of the other slides I had. We've got just a few more minutes. A couple other things that I had is I did want to talk a little bit about membership. This is something I have been very lax about, um, trying to, increase income and so on and so forth. And part of why we've been able to do that is we don't have any paid staff. I do this pro bono. It's a labor of love. Like I've said so many times, I couldn't stop doing this. I just think that the world needs this, and I don't see it happening a lot of other places. So, um, but we do, and we really should. I need to start focusing a little bit on trying to build a budget so that someday we can hire paid staff. I intend to live another 30 years. We'll see if I'm successful at that. But, at some point at least, we probably need to hire some folks. So the membership dues also help us sponsor events like the Colorado Hydrogen Day that we had this October. And also, I think that, if you throw a few dollars our way, it really gives you kind of a sense of ownership and feeling like you're participating and kind of helping. So, we really have created some very affordable types of memberships. We didn't have this until just last year, but the individual and startup company dues are very inexpensive. Individual membership is 50 a year, and startup companies is 200 a year for the first 2 years. Those are Colorado Hydrogen Network membership only. They do not include CCIA, the Colorado Clean Tech Industries Association. And then the corporate membership is actually a joint CCIA CHN membership. And it's a little more expensive. It's really intended for corporations, and the dues are based on the number of employees. So if you want to ponder this a little bit more, if you go to the Colorado Hydrogen Network website, and you can see at the top here, if you hover over members, the join will pop up. And if you click there, you get a table that talks about what the different memberships are and whether they're tax deductible or not. If you're interested in individual or startup, you can click this button down here, individual startup. If you're interested in corporate, you can click that. Please do not feel obligated to do this. Participation is always open to everyone at no charge. If you're with a corporation and they say, no, we can't afford this, it's not in the budget or whatever, but you'd still like to take part, and if you want to join as an individual, that's perfectly fine. Nothing wrong with that. And if you want to continue taking part in our meetings and newsletter and everything else without paying, that's absolutely fine too. But like I say, I've been pretty lax about getting out there and sort of asking folks to help support us. We did deplete quite a bit of the budget we had for Hydrogen Day, and without a sponsor for next year, for 2025, we may not be able to do that. So if that's a little bit of a motivation to you to throw a few dollars our way, that's fine. We also have a donate button, which I'm not sure if this is up and running yet, but if you're somebody or a company or something just wants to give a one-time tax deductible kind of thing, you can do that there as well. So enough said, but I just hope everybody kind of considers that, and I'll probably keep mentioning this throughout the year. A few things in the news I wanted to cover, and this actually appeared in Alan Best's Big Pivots, showing this is a map of the state of Colorado and what the departure from normal temperatures in degrees Fahrenheit was in just part of December. And okay, just a small snapshot of time, but you can see there's an awful lot of red on here. This cold apparently was real. They thought maybe it was an anomaly in the data, and not sure for the reasons for that. But the point to all this is, and I'm preaching to the choir, I'm sure, that the planet's burning up, and we really need a plan to address that, which I said next slide, but it's actually, let me go to the actual slide here. Sorry, got myself out of kilter here. I'm working right now with the Colorado Collaboratory as well as the Colorado Clean Tech Industries Association to see if we can join forces and put together what I'm calling a clean tech hub. We had the hydrogen hubs that came around, but I think that this is a little bigger than that, because I think a lot of these sources and uses of energy intermingle. And so I think it's important to have an overall plan, and want to also try to involve the Colorado Energy Office in this and see if they're interested. But I've shown this before. Some of you that have seen it probably aren't as intimidated as those of you who haven't seen it before. But on the left here, we've got all the sources of clean energy. And you notice featuring pretty prominently is hydrogen wells, that's natural hydrogen, and then the underground generated, which is like we just heard from Gold H2, using biology to convert petroleum to hydrogen, or the proton H2 technique of using oxygen injection. And obviously, though, that hydrogen can be used as is, but if you have a situation where you have a data center that needs electricity, maybe you use a hydrogen well to run a turbine that. So this this crossing of paths, I think, is important to be understood by all of the players that are in the clean energy space so that we can collaborate. As Buford just said, the hydrogen network has been great for bringing people together, but I'd like to take that to the next level to start bringing in the geologists, start bringing in the oil exploration folks and the geothermal folks, and saying, hey, let's cooperate together here. Maybe we can find a source and a need out there and put together some of these pieces of this puzzle rather than just have somebody build a geothermal plant and just hope somebody's going to buy that. So at any rate, this is the kind of plan that I think we need. And I'm going to keep pushing this statewide, and then we'll kind of see where it goes. So kind of going back to why do we care about hydrogen for transportation? Well, I keep looking at the public opinion polls out there, and it's not really good for getting 100% adoption of zero emission vehicles to replace all of the internal combustion that's out there. Here's a recent poll. I don't know the date on this. I think it's just in the last month or so that AAA did, showing that the intention of people to buy battery vehicles has been dropping. Also, and then this is worldwide, 29% of electric vehicle owners are considering switching back to combustion engine. And that's by a poll by McKinsey. And some of you may have seen that Ford is temporarily halting production of the EV Lightning pickup just because the demand is low. And that could just be a little bump in the road there. Hopefully that'll come back. But the point is that I want you all to be armed with with information like this when you're talking to people, so you can say, look, battery electric vehicles are not going to replace 100% out there, even of passenger vehicles, and certainly not of the medium trucks like the box trucks and flatbed trucks out there, and certainly not the large over-the-road Class 8s, 18-wheelers as we call them. This is why we've got to have hydrogen, and this is why I keep pounding my shoe on the table about needing hydrogen. All right, I'm going to skip over that. Last thing here, we've just got a couple minutes left. As I always do, I put a podcast update up, but I do want to let you know there's been a dry spell of quite a few weeks, and just released this new one with Alicia about biologically deriving hydrogen from oil reservoirs. So definitely check that out. It's a pretty quick podcast, so you can give that a listen. So with that, I don't have anything else. If anybody else, we've got just a couple minutes. Any other questions or comments, please feel free. Oh, Elliot's got his hand up. Go ahead, Elliot.
There I go. How you doing, guys? Hey, I really appreciate you acknowledging the people that are really rolling up their sleeves and putting the hard work into it. And obviously, it's a lot more people than that. But had a chance to get to know some of the people involved. Well, all of the people involved that you awarded, and they're all specially dedicated to what we're trying to accomplish in this industry. I think right now, in light of we know what's occurred in the political realm. I think that cooperation and working together here in our industry, which we've been doing, but also reaching out and working with. There are players in the oil and gas industry that are very willing to take a stepping stone approach to blue hydrogen and outbound to cooperate and work with them as we build our technology, as we find the capability and the funding to do the exploring for natural hydrogen. I think that's pardon the pun, but it's a natural fit for those exploration companies to get involved. They have deep, deep, deep pockets. And when somebody says drill, baby, drill, maybe we drill for hydrogen instead of more oil. And I think that the oil companies would probably like that because they're very comfortable where they're at. They don't want the price too high and they don't want the price too low. If there's too many wells drilled, then it drives the price down and it skews their bottom line quite a bit. So I think from that perspective, we have a lot of talented educated people in this industry that we need to all fight together to work with what is available for us to work with, and to know that at some point in the future that will change what's already occurred and what's trying to be occurred right now. And we need to be resilient. And you know as our company, we're fighting tooth and nail just to survive, with great concepts, great ideas, great partners, but the money's not there yet. And the hope of any kind of federal funding just essentially evaporated in the past couple of days, at least for now. And so working together with the industry people that are willing to step forward, I think is something we need to reach out with as an industry and not individually.
Well, thanks, Elliot, and definitely wish you the best of luck with your endeavors. And once those get off the ground, we'll get you a Hydrogen Heroes Award too. But
Well, I'm
we've
not
got
in
a
it for
couple
the
other.
awards. I'm just in it because it's the right thing to do, just like you.
I know, and bless you for it, and keep going. We've got a few more hands. I want to try to grab a few of these. Keith Whipke's got his hand up. Go ahead, Keith.
Actually, I was third in line. Ross and Bill were before me.
I couldn't tell. Sorry.
That's okay.
Oh, go ahead. Oh,
You can go ahead, Bill. I had a quick question afterwards, but you can go ahead, Bill.
Hello, can you hear me?
Yeah, go ahead, Bill. We're out of time.
Yeah, a couple of comments on your last diagram. The picture is going to change dramatically. The posture, the competitive position of hydrogen, if we can make hydrogen where we need it. That is, from geothermal anywhere, we make hydrogen anywhere. We don't really know where we are, but we seem to be going in that direction. So stay tuned. That would make a world of difference if we don't have to move the stuff and store it.
Yeah, I agree. Geothermal is going to be huge. I think someday we'll look back at wind and solar and say, yeah, those are kind of niche, but geothermal and maybe natural hydrogen wells are the way to go. All right, I'm going to keep going fast here. Ross, did you drop your hand?
Yeah, it was a quick food for thought thing for maybe a topic for another time. I'm throwing it out there. Thanks for letting a city slicker talk in the Colorado meeting. I wish I could visit Denver and the area more often. But just two kind of things that are in the news that make me wonder about the market being kind of ripe for a disruptor opportunity with a hydrogen vehicle. I know that there's these, all the major auto manufacturers, just like the major oil companies, want to maintain their control of the market. But there's also something in the news that I think a lot of more heavy industry truck users are aware of. This right to repair is going away. And there's like, for example, in the news, John Deere is moving their facilities out of the US, I think, because, well, not directly related to the right to repair, but I think that there's this sort of like regulatory capture issue going on that we as a network, I think, are the people who could be the loudest voices and the most effective for developing solutions for these challenges. But the other thing that goes hand in hand with that is, automotive manufacturers are making cars more and more complicated, more and more expensive to repair. How about designing a car that's designed for reliability and repairability instead of all these other features? So keep it as simple as possible, but also have the technology that we need. And then on top of that, the final point was just electric cars are in the news and somehow they're skirting a lot of accountability and responsibility for these massive lithium ion battery factories that are on fire from the west coast of California to Newark. In the harbor of New York City last summer, a whole freightliner was on fire for a month and nobody paid attention, even in the middle of New York City. So it's kind of interesting. We have this concern about hydrogen and the public perception, but meanwhile, the electric car industry is getting away with so much already. So just kind of food for thought for another topic another day maybe, but just wanted to raise the point.
Oh yeah, we could do a whole series on that, I think. So, but thanks, Ross. And I usually try to cut this off right at 5, but I do want to hear what Keith has to say. Go ahead, Keith.
Yeah, I'll be quick. Just a quick highlight or low light. I was in Long Beach last week for the Fuel Cell Seminar. Outstanding conference, really well attended by not only industry folks, but government folks. But the day before that, I took an opportunity with some other NREL staff to visit a hydrogen fueling station kind of in the eastern part of the LA area. And we were there to see a liquid hydrogen transfer from a tanker to the station That's why we went there. But while we were there, the station was actually down due to a cryo pump failure on a Sunday, and this was on I think this was on a Tuesday or maybe Monday afternoon, but it had been on their station notification system for a couple days that this station was down. But while we were there, in the 3 hours we were there, between 8 and 10 hydrogen fuel cell cars came up to the station anyway. There's 4 fueling points. 2 of them had to get towed away on a flatbed. Many of the other 6 or 7 that left were swearing about the car and how they hated the car. And of course, it's not the car's fault. They can't get the fuel. The cars are outstanding. So it just was I've visited a lot of hydrogen stations in California over the 20 plus years I've been in this field. And I don't think I've ever seen such a visceral negative response to the fueling infrastructure problems they're having there. And it's just it was a wake-up call and reminder for me as we head toward heavy-duty hydrogen fueling stations, where it's not going to be an emotional thing, where you're attached to your car emotionally or not. It is a pure business decision, and they will not keep the trucks regardless of what they've invested in them if they're not working, because they can't go out of business not delivering product. So it will be a very different experience, and I think it will be a much shorter, quicker honeymoon period than light duty had or has. So just it burned a memory in my mind about how those people felt about the vehicles, and made me think about the heavy duty industry and how it's just going to be very different, and they won't tolerate 2 days without fuel at a station.
Right, even 2 hours. Well,
Yeah.
this is a thing that keeps all of us, I'm sure, awake at night. It's certainly me, and we've got to do better here. I know we've got NREL involved with the 3 stations that are going in to try to help us get every bit we can out of the lessons learned that came out of California. Um, I mean, unless you throw huge amounts of money at it, you can't make it multiply redundant. But um, we hope to do much better here. I think with on-site generation, as long as the equipment's up and running, of course, we're not going to have interruptions of supply and things like that. But yeah, it's tough, and this is so nascent to have these, um, have your legs chopped off at the knees right away, like California's got going on with the faults they've got with their systems. It really hurts the industry, and certainly gives a lot of ammunition for people to criticize hydrogen, which we really don't need right now.
Yeah.
Yeah.
Thanks.
All right. So I usually cut this off at 5, but this was important stuff. I wanted to keep going. But thank you, everyone, for your participation, and we'll see you online again in a month.
Thank you, Brian. And thank you so much.
Yeah, you're welcome.
All right. All right.
Thanks,
Thanks,
Brian.
Brian.
Yep.
Thank you,
Take care, everyone.